Series in our deep learning tutorial series. The last time we were trying to look at some code in the back propagation and the forward propagation. So today we shall continue from that and look at our computational graph. Remember, we mentioned that for us to be able to properly do forward and back prop, it is easier to put all these computations in a graph. And so we have seen this a couple of times. Our forward pass start from the input. This is the input. We have the input in this place. So this is our input, and then it goes this way to the right. This is our forward pass. Remember that once you get to the end of our forward propagation, we compute the loss, which is the difference between our prediction and the target label. Then we get the sum of the loss, which is the total loss based on our number of batches that we're using, our training example. Then we do a partial derivative of the total loss with respect to each of the parameters that we have in our computational graph. So by the time we do that back, this gives us a backward propagation. So as you can see in this list, this is our forward pass, which is the weight matrix multiplied by the input x, and we had the bias. Whatever result that we get there, we feed it through a nonlinear function. The nonlinear function helps us to be able to learn some complex curve through our data point. So this is through sigmoid, and this activation function becomes a representation of our x1, like we have explained in previous series. And so this replaces our x1 because it's now represents, it encapsulates whatever it is in our input. We also call it the feature representation. So this is what we multiply with the next set of bias weights and plus the bias. Whatever we get here, we pass through a nonlinear function to get this, and this is our loss function, and this is the loss function for logistic regression. We're going to look in more details all these loss functions in subsequent tutorials, so stay tuned for that, how you actually formulate a loss function for your own specific project, because loss function, which is also the objective or cost function, is very important in any machine learning or deep learning models or algorithm building. In a backward pass, we do a partial derivative done of our total loss. We do a partial derivative of our total loss down. So we'll also take a time to also look at backward pass in greater details in some other tutorials. Okay, now as you can see here, this is our final prediction, this is our target label. Then we get the difference, then we compute this and forward down. So backward propagation for deep neural network, we carefully define variables and track their dimensionality, understand the variables, the weights, the biases, keep straight what variables feed into what computations. As you can see in the graph, we have some earlier weights feeding into later weights. We work with vectorized equation. We put in the vectors, compute all gradient at once. So this is, you differentiate the loss with respect to the weight instead of doing one after the other. We reuse derivative computed for higher layers in computing for lower layers so as to minimize computation. So backprop in general computation graph is a forward prop, is backward prop, we visit nodes in a topological sort order. That is, first of all, compute the value of the node given the predecessors. So start with the predecessors, compute the value of the nodes. First of all, we'll do a backward propagation and initialize the output gradient by doing partial derivative of the loss, and you get 1. You visit the nodes in reverse topological order. You compute the gradient with respect to each node, like we have mentioned in the examples that we saw in earlier tutorials. So this is partial derivative, so we have intermediary variables. If you want to do dz dx, then you have to go to the intermediate variables. You do your big the forward probe and backward probe in big O complexity. In general, neural networks have regular layer structure, so we use matrices and Jacobian most time to be able to feed in all these computations, and that is why neural networks tend to be very good with GPUs, because GPUs can work on parallel processing matrices at the same time. So automatic differentiation, so the gradient computation can be automatically inferred from the symbolic expression. Each node type needs to know how to compute its output and gradient with respect to input. Modern deep learning frameworks like TensorFlow and PyTorch, they do backpropagation for you. I mean, leaving the layer or node to and calculate the local derivative. So this backward backpropagation implementation, this is the forward pass and this is the backward pass. We want to take a look at that code. This is implementing forward and backward pass. If you want to implement the partial derivative yourself, this is the output and these are the input. So forward stroke backward pass is the forward, is the backward. So backward propagation, the conclusion is, it is very important for us to know that to calculate the downstream, you multiply the upstream by the local gradient. You remember that the upstream gradient is what we start from the loss from the end. Then we have intermediate variables that we do a partial derivative with, and you multiply it to be able to get our downstream. Once you calculate a downstream for one, it becomes the upstream. Then you calculate the local gradient, then you multiply with the upstream. That's very important to understand. So that is recursively we do that, because downstream keep changing to upstream and continue like that. So implementation, maintain a graph structures. Forward back, complete the result operation. You can save the intermediate. Backward, apply chain rule to compute the gradient of the loss. So while learn about gradient and backpropagation, modern deep learning framework compute gradient for you, so you can use standard library API, but you need to understand what's going on in the hood. And in some separate series, we're still going to look at some work example of this forward and backward propagation. It's good for us to understand what is happening under the hood, even though most of these things have been implemented for us in modern deep learning API. It's good to understand what's going on. So thank you very much for listening. See you in the next tutorial.